Welcome to day 10 of our C programming journey. Today's topic is file handling in C, a foundational concept crucial for building real world applications. Think about programs like Notepad, Excel, or even video games. All of them store data somewhere so that when you return, your data is still there in C. This is accomplished using file handling function. File handling allows a program to interact with the computer file system, letting it create, read, write, and delete files. Instead of storing data temporarily in variables, files provide a way to make data persistent across multiple program executions. What will cover? Why file handling is important. File modes and types. Core functions fopen, fclose, fprintf, etc. Text versus binary file operations, error handling and best practices. Discussion prompt. Ask, can you name an app can use that saves your data when you close it? How do you think that works? Introduction. File handling is the bridge between short-term memory and long-term storage hard disk. In C, we see file handling when you want to store user input for later use, read configuration settings, log problem actions, share data between different programs. Imagine write a content book app. Without file handling, we would have to enter names every time we can run the program. But with file handling, those contacts can be stored in a file and retrieved whenever needed. Why it matters? Programs became more flexible and useful. You can handle much larger data than fits in RAM. Enable programs to run in automated environments. Example, log for search. Ask student to write down one scenario where they would needed store data permanently. Why file handling? Let's look deeper into the practical uses. Persistent storage keeps data behind program execution. Data exchange facilities input output between programs and systems. Efficient memory usage avoids memory overload by saving large data sets externally. Login and tracking useful for debugging, error monitoring, and audit trails. User customization allows apps to save preferences. Example, dark mode settings. Real world example, saving high score in a game, storing from data in a registration system, writing logs for a service. Question for to the students. What happens if a program crashes and did not save its program? How would file handling prevent data losses in such cases? File handling functions. C provides several built-in functions for working with files. Here are the most commonly used ones. File means open or create a file. Fclose, close a file. Fprintf, write format output. Fscanf, reads format input. Fgets, read a line from a file. Fputs, writes a string to a file. Each function performs a specific role. Fopen means connect your program to the file system. Fclose means ensure the file is properly saved and closed. Fprintf and fscanf are file-based version of printf and scanf. Fgets and finputs are useful for handling strings. Fopen function syntax. File star file point equal to fopen file name mode. File f pointer declare a pointer to a file. File name the name of the file to open. Mode determine how the file will be opened. Read, write, append, etc. Available modes are read only, W write only, A append, R plus read and write, W plus write and read, A plus read and append. Important. Always check if a file returns null. This indicates a failure. Example, file does not execute or permission denied. Iterative task. Ask a student to write a simple program that opens a file and prints success if the file open or error otherwise. Close function. Once we are done using file, you must close it with fclose. Syntax: fclose f point. Why it's important? Ensure all buffer data is properly written to the file. Free system resources, prevent data corruptions. One of the example is the consequences of skipping fclose. Data might not be saved. You could exhaust system file handles. Engagement. Ask, what do you think happens if you write to file but don't forget to close it? File opening modes. Here is a summary of common file opening modes. Mode and description. R means open for reading, W means open for writing, E means appended to end of file. R plus means read and write, W plus means write and read, A plus means read and only. Use cases. Use R when reading a config file. Use W when creating a fresh log file. Use for appending new data like charge logs. Iterative challenges. Ask if I want to keep adding data to a file without losing existing content. Which mode should I use? More details. Let's understand the file details of these modes. R open file for reading only. File must exist. W means open for writing. Create a new file or overwrite if it is exist. A means open for writing at the end. Create a file it does not exist. Modes with plus equals to allow both read and write. Compression example. Open the same file in W versus A and show how exit data is treated. Extra tip. Use A plus when you want to read existing data but also append new content. Blank and transition slide. You can use the slide to take a short recap or introduce a quiz. Quiz type. What method would be used to open a file for both reading and writing without losing its content? What does F open returns on failure? This is great point to pass and take questions. Example F open file. Let's see a practical use of F open. File F pointer fp equals to F open data dot text or if open null print file cannot be opened for n return one. Explain line by line. What is file pointer? Why check for null? Demo. Run this code with and without the file present. Show different outputs. Modify the example to open a file in write mode and write a line of text. Input and output file IO. In C, input and output operations involving files are known as file IO. These are distinct from standard input and output functions like scanf and printf, which deal with the console. File IO allows us to read from and write to files stored on disk. There are two main operations. Input means reading, retrieving data stored in a file. Output means writing, sending data from program into a file. This is crucially in scenarios like reading configuration files or storing application logs. Unlike variables that lose their values after the program executes, files help maintain continuity between sessions. C creates file as a stream of bytes and standard IO function manipulate these streams. These streams are associated with file pointers of a type file. The standard library sdio.h provides functions such as fscanf, fprintf, fgets, and fputs that facilitate this interaction. Each function is designed to handle a specific kind of IO, whether format and or unformat, character based or line based. Understanding how to navigate between these methods is essential for designing efficient data driven application in C. fprintf. The fprintf function is a file version of printf and it is used to write format output to a file. It supports all standard format specifiers. Example percentage %d, percentage %s, percentage %f that could be used in printf. Syntax fprintf file pointers format string variables. Example fprintf f name percentage per n age percentage d per n name and age. This is a function is useful for writing structured data like logs, reports, and records. It's especially powerful when combined with the loops and conditionals to output multiple entries. A key advantage of fprintf is the ability to control formatting directly, allowing consistent and readable outputs. It is commonly used in tasks such as logging program execution, saving game scores, and exporting results. Before using printf, always ensure the file has been opened successfully. Writing to an unopened or null file pointers will result in runtime errors or crashes. Also remember, unlike console output, content written using printf is not visible unless you open the file externally. Scanf. Fscanf reads format data from a file. It is work like a scanf but takes file pointer as the first argument. Syntax. Fscanf file pointers format string variables. Example fscanf percentages, percentage name and age. It's typically used when the data in a file follows a predictable format, such as structured column of values or key value pairs. You must be cautious when using fscanf. It does not handle space in string well. It assumes the file contains exactly what you expect. In deviation, may causes incorrect reads or runtime errors. Always check for end of file using feo or return value from fscanf to ensure you are reading correctly. Using fscanf is the best suited for reading records such as student marks, configuration, setting, and numerical data. Fgets. The fgets function is used to read a complete line from a file, including spaces. It is a safer and more flexible way to read string compared to fscanf. Syntax means fgets string size file pointers. Example: Caroline 100 fgets line 100 fp. Unlike fscanf, which stops reading at the first white spaces. F gets continuously until it hits a new line character or reach the size limit. This function is ideally for reading text where spanning is important, such as paragraph, messages, or comments. It can also handle black lines, special characters, and longer strings more gracefully. One important thing to note is that f gets return the new line character at the end of the string unless it hits at the end of file. This function is often used when reading configuration files, user comments, or lines of code. Puts. The fputs functions write a string to a file. It is similar to puts but operates on file and does not automatically open a new line. Syntax. Fputs string file pointers. Example: fputs hello world for n fp. Use fputs when you want to write plan a string without additional formatting. It's particularly useful when saving logs, status, manage, or predefined content. We can write multiple lines by manually including per n in the string. However, if you need to include variables or format data, printf is more suitable. Fputs also writes a character as is, so it is ideal for exporting raw data, structured logs. Fputs means writing to a file open in a read-only mode will result in failure. Example program writing. This slide introduced a complete example of how to write data to file using the file handling function we have learned. It is simplified structure of such a program. The file is opened in write mode, which creates a new line or overwrite an existing one. A simple string is written to the file using fprintf. The file is closed to save the content properly. It is crucial to handle potential errors by checking whether the file pointer is null after attempting to open a file. This kind of program is used in scenarios like generating reports, logs, and saving data that user inputs. Example program reading. Now let's move to the reading from a file. Below is a basic example. The file is open in read mode or a line is read from the file using fgets. The line is printed to the console. This example is fundamental for application that load stored data, such as saved setting, recent documents, or logs. You can extend this by reading multiple lines in a loop until FU become true. File pointer check. Always verify whether a file has been successfully opened before using it. This prevents runtime error and potential crashes. If open files, it returns null. Pre-error gives a system-defined message explaining the error. Example: no such file or a directory. Common reason for failure: file does not exist in read mode. Insufficient permissions. Invalid path. Making this check a standard part of your code. Improve the reliability and user experiences. Working with text files. In C, text files are the exist to work with and most familiar to beginners. Data is stored in a human readable format and strings. Let's say we want to write a student name and score. File equals open the file student.txt and write mode. Printf John 90%. Close the file. F open student.txt W. Open the file for writing. If does not exist, it create it. Fprintf works like printf but output to a file. F close the file to ensure data is saved. When you open student.txt, we will see John 90 perfectly readable, great for logging, config files, etc. Binary files. Text files are easily but not always efficient. Entry binary files. They store data in the same format, exist in a memory, no conversion, no formatting. Suppose we define a one of the example. To save this directly, struct students s equals to Rajeshwari 101 8.7. Fwrite s size of 1 of write the entire student struct in one go. No need to convert to text. Faster and more compact. File modes. Binary modes are just like text but within a AB suffix. RB read binary, WB write binary, AB append binary. Example: file pointer FP equals to F open data.dn. WB is create or overwrite a binary file. Use it when storing large arrays, records, or memory structures. Fwrite and fread. To write a binary file. Fwrite s size of 1. Ampersand s is the address of the struct. Size of s is how many bytes to write. 1 mean one block of that size. To read. Fread ambiguous is size of s 1 FB. You read data back exactly as you write it. This avoids parsing errors. What goes in come out the same. Text versus binary. Compression. Let's compare. Future text file, binary file. Readability, yes, no. Size larger and smaller. Speed slower and faster. Portability, high and low. Example: saving 100 students in text may take 10 KB. In binary, just similar to 2 KB. Choose based on your need. human readability and efficiency. Memory layout, structure versus union. Let's break down how memory is allocated in a structure versus union. Union save memory because memories occupy the same space, but you can use one memory at a time. Use the structure when you need all fields. Use the union when you need only one field at a time and want to conserve memory. Example for binary read. To read file star fp equals to fopen record.bin rb struct students s. If pointer not equals to null, open the bracket fread ampersand s size of s 1 fp fclose fp printf read percentage s percentage d percentage to f s dot name s dot id s dot gp. We will see read Nina 102 9.0 just like that, accurate and fast. Common file handling errors. Watch out for this. File does not open. Maybe it does not exist or permission D name. Wrong mode. Using R instead of W when writing. Third, format mismatches. Using percentage %d for string can crash your program. Fourth, forgetting to close. Fclose is critically it flashes before and save data properly. Always checks return values. If fp equals to null, open the bracket, p error, file error, close the bracket. This helps checking debug issue quickly. Summary. To summarize, use fopen, fclose to manage files. Use fprintf, fscanf, fget for text files. Use fwrite, fread for binary files. Always check for errors and choose the correct file mode. Use text for simplicity, binary for speed and structure. File handling is crucial for real-world apps like data login, file-based databases, or saving game states. Final thoughts. Mastering file handling makes your C program real-world capable. Try building a mini project, a content manager or quiz system that saves you loads data from files. It is excellent practice and show how to important persistent storage really is. That is for today. Thank you. Please like, share and subscribe. Happy coding.